Okay, so today what we're going to do is called translation of quadratic functions. Translation. To translate in math means to move. You move. And moving means we're going to move on a coordinate plane, on an XY coordinate plane. So there's really just two types of motions we can do because it's two-dimensional. You can either move right or left or up or down. And we're going to discover how to do that so that you can take a quadratic function and put it wherever you want. So go to the graphic calculator. I want you to go to the graphing calculator, please. So everyone go here. And let's see, this is, okay, basically what they're showing us is fine. There. So go there. And so is everyone there? I just want to make sure we're all on Desmos. So make sure you're on Desmos and there, and then we're going to enter in, we're going to start a family. We're going to have a family of functions. And a family has to have a parent, right? So this is going to be my parent function. I want you to type the same thing. F of x equals x, and then shift 6, so you get the caret squared. And let's see, do I like that color that's in red? That's good, I like that. Okay, leave it in red or whatever color you like. Doesn't have to be red. So this is the parent function. We've talked about what this shape is called. Does anyone remember? Parabola. It's a U shape, but it's called a parabola. And this is going to be our parent function. So that's why we're calling it f of x. So we're going to have a child function. So hit the plus sign. And we want another expression, f of x, but we're not going to call it f of x. Let's call it g of x equals. I'm going to do this one a little different. Okay. Let's start with x squared. So everyone looks a little bit like their parents, right? So g of x will have x squared, definitely. But now I'm going to put plus k. So everybody do this. G of x equals x squared plus k. Go ahead and put that. And you'll see that little button below asking you, do you want to turn this into a slider? Do we want to turn this into a slider?
Yes.
Yeah, let's do that. Let's press on this x squared, and we're going to turn this into a slider. But I want you to click on one of the numbers. And let's see. Yeah, let's go from negative 10 to 10. So negative 10, 10. And let's make the steps. Oops. Make the steps 0.5. Okay. And move this over to 0. There. Move the slider over to 0. So did everyone catch that? It's from negative 10 to 10 for k, so it's going to range from negative 10 to 10. And then we're going to move every half. Okay? And put the k at 0. K equals 0. Okay? Everybody there? So right now we have the parent function f of x. And what's our child function? What's g of x? It's x squared plus k, but what is k? 0. So couldn't you say they're identical?
Yes.
And absolutely they're identical. Let me erase this parabola thing. So both our parabolas are identical because they're identical. Well, let's move this over to 2. Move your slider to 2. And that's the blue one. You know what? So I can tell the difference. I'm going to hold and press on this. I'm going to make this that. So I just held on it. You held on the color. And I could change my line over to this dotted line. I kind of want to tell the difference. So now, changing that to 2. So now this is x squared plus 2. X squared plus 2. How is the graph different? What happened? Here's my parent function. Here's the child function. Yes?
The y-intercept is 2.
Yeah, but how did that change or shift this? How did it shift? Jesse?
Our lowest point is now 2.
Our lowest point is now 2. Yeah. So it went from here, moved up to 2. The vertex, remember we call that the vertex? So the vertex and everything else went up to 2. What would happen if I shift this over to 6? If I make it x squared plus 6, what's going to happen to our graph? Yeah. It literally pushes it up to 2. And I could pick everything else in between. Right there, I'm at x squared plus 4. Moved it up 4 units. What if I go on to the negative side? Oops. Well, that's a negative minus 0.5. What happened there? It went below. And I could continue pushing it down by making it further negative. So here's x squared. There's mama or daddy. And there's a parent function. It's going down. It shifted down from, the vertex went down to negative 4. So basically, putting this plus k or putting a constant behind your x squared, how does it change the function from where it started, from its base or parent location? How does it move it? Up or down? You see that? If I put positive numbers, it'll push it up. If I use negative numbers, it'll push it down. Okay. So I can basically control where I locate my x squared, my parabola, up or down by anything I want. Okay. All right. So now we're going to add something else. Put it back at 0. Let's go back to 0. So put k back to 0. And now we're going to play around with this parent function a little more, or the child function. So now do this. To g of x, put it in parentheses and put x minus h squared. Do that. So we're going to have x minus h squared plus k. And we know k, that constant, that plus k, will push it up or down. What do you think that h is going to do? Yeah, it's going to move it left or right. Okay? Now the question is, do we want to make a slider? Yes. So I'm going to go here and press add slider and put it at 0 to begin with. This one has a lot of wiggle. Okay. So I'm going to go to over here. do the same thing. We're going to go negative 10 to 10, and the step is going to be 0.5. Okay, let me just pause. So I'm going to let you play with h. Leave k by itself, but move around the slider for h. See how you can get command of this to move right or left wherever you want. So if you want it to go to positive 6, what do you have to do? If you want it to move to negative 8, what do you have to do? Play around with it. Just slide it around. See what the net effect is when you slide this way. And when you go this way. And what number would that give you in the function? Think about what number that would give you in the function. Because ultimately we want to write a function that would move this vertex wherever we want to go. We want to have command of the vertex so it can go wherever we want. So play around with it and see if you can figure out what the actual function would look like for that. Okay, so play around with it. I'll give you a couple minutes. Okay, so I moved my g of x over to have a vertex at 0, 6, or 6, 0. What would the actual function look like? What would I write in as the function? G of x equals x squared, and what would I put? So I can move it over. Plus 6. Let's test it out. Well, I'm going to call it h of x. I'm going to call it h of x. And I'm going to add that. So let's all add that. Up here, let's call it h of x. And then equals, parentheses, x plus 6. This is going to be kind of our play around one. Squared. Okay. Oh, I can't call it h because I already used h. Let's call it p of x. There. I can't call it h because I already used h for something, guys. And I don't like blue. I use green. So there it is. Did it move it over here? Did it move it to the right? What did it do? It moved it to the left. So what would I have to do to this h of x to move it so this green one overlaps the dotted one? Plus 6 isn't going to do it. Yes? Make it negative. Let's try. Yep, that did it. So p of x, the one kind of that we're going to play around with, had to be x minus 6 squared. Huh. But it didn't. H is positive here. How does that work, though? If it's positive, why did I end up with x minus 6? Go back to the original model. What does it have here? Minus, right? Minus. So if I put, notice that if I want to move that, let's move this to negative 6, or make this h negative 6 rather. So now the number h is negative 6. So what's a negative negative? Positive. So let's go back over here, change this minus to a plus again. We already know the answer, but how did that work? What do you think? How is that? How is this working? Like if I want to put the vertex at 4, 4, 0, how would I have to change this? X minus or plus 4? Do I want a minus 4 or plus 4? Yeah, I want a minus 4. X minus 4 squared. How is that working? Why does it have to be minus 4? What number is here, positive or negative? Positive. If I substitute this h in here, what would my equation look like here? X minus 4, right? But if I make it negative, right? What's what's minus negative 4 going to be? Positive, right? And sure enough, if I move this over, make this a plus, that's where it goes. Okay? So it's kind of the opposite of what number you're plugging in. If you're plugging in a positive, it's going to go this way, right? If you're plugging in a negative, it's going to go that way. So it's kind of counterintuitive of what you see a plus, it's going to go to the left. If you see a minus, it's going to go to the right. Okay? So I'm going to give you a location, and I want you to locate this particular graph. Say I want to put it over here. I want this to be the vertex. 4, 2. 4, 2. Let's all do this together. So we're going to play around with the H's and K's. Let's try to put it where it belongs. First, move it up 2. How would I move it up 2? No, up 2. Which one do I put plus 2 to, H or K? Okay. Let me get this at 0. Okay. And I want to move this over to plus 2. Okay. Now I want to move this to the left 4, to the right 4. And there it is. Now, how would I write the function over here? How do I move this green one into that location? What would I write here? Think about that for a minute. Think about that. Take what you know here, take these numbers, take what you know here, and we're going to rewrite P of X so that this green parabola moves over there. Take the numbers we already have, just plug them in. I put plus 0 for the time being. I'll just do that for right now. So the green one is overlapping the parent. Okay. So I want to move this over. What is P of X? If I want to write the function, what's it got to be? Change. Okay. How about the inside 0? What does it become? I see a 4 for H. Is it plus 4 or minus 4? Minus 4. Let's test it out. Okay. What was the K value going to change to? And there it goes. So the equation would be X minus 4 squared plus 2. Okay. Okay, I'm going to put these back at 0, so that did it. I'm going to put these back to 0, so put those back to 0. Let's move these back to 0. And this time, let's put the vertex. Okay, let's put the vertex here. So the vertex is at negative 6, 4. So play around with the sliders here, and then write the function. So first play around with the sliders. So move these over wherever you need to go, up and down, right or left, however much. So you get g of x to where you want it, and then figure out the numbers you have to replace the zeros with to get this going the same way. I'll pause this for right now. So if you're playing at home, do the same thing. I got the sliders where I want. How do I write it for p of x? Let's replace the plus. What am I, the zero that's outside for k, what number goes there? 4. Okay. How about that zero here? And put it there. How can I simplify that though? Yeah, that's double negative. That's why it's basically counter of the opposite of what we normally would expect, because that double negative. So I'm going to simplify this and write this as x plus 6. And there it is. Okay? All right. So I'm going to give you one more. Negative 2, negative 4. So the vertex goes here. So move the slider so that it moves here. So play around with those sliders again. I want to bring it down. And then I want to move this over. Okay. And now what do we want for p of x? Well, let's do the outside one. That seems to be the easier one. What number do I want here? Negative 4. Negative 4 on the outside. The constant, it's negative 4. What do I want inside? Plus 2 or minus 2? Plus 2 or minus 2? Plus 2. Okay. So do you think you can put this anywhere you want now? Can you locate? So if I say, okay, put it here. Without the sliders, give me the equation. What would put it here? P of x here. So I want to move, first the up and down. The up and down is pretty easy. I want to go down to negative 2. My coordinates are 6, negative 2. Okay? 6, negative 2. Challenge yourself. Without using the sliders, think of what equation would put that here. So what number would I want for the constant, the outside? Yes. Negative 2. Okay. And what would I want for the h? What number, plus or minus? Minus. There it is. Okay. Final challenge. What if I want to flip this? Okay. What if I want to reflect it? It's called reflecting. In other words, it's opening up. What if I want it opening down? Make this the maximum. Huh? Negative in front of the parentheses. Negative in front of everything. So a minus at the very front. Do that. Okay. If I put a negative here, it would do that. Okay. So for today's IXL, it's basically this. They're going to either explain to you or show you a graph and they'll say, okay, give me the equation for this graph. And all you really have to do is figure out how these numbers would look. Basically, where are the numbers? I recommend just keep this Desmos out and test out what the equation you think should be, and then before you enter it in. So basically, the IXL is called transformation. They're going to give you f of x. It's always going to be x squared. And then they're going to tell you what to do. They want you to translate this 5 units up. So if you want to translate this 5 units up, so it's going to be x squared still. And then you want to translate 5 units up, I would just plus 5. I would push it up, right? And there it is. So you could test out your theory on Desmos and then take it from there. So that's the assignment. It's on IXL. I recommend have Desmos out. Try your function before you enter it in. And if you get exactly what they're asking, then that's what you would enter in. Okay? All right.